Okay, good afternoon, everyone. I hope you all can hear me. Right. So, in a previous session, you all looked at what AI is and how we can, use AI in different, applications. So, in today's session, what I'm trying to focus is mainly on how we can uh, specifically use these machine learning models or AI models in our applications. So last time you all looked at what AI ML is and the applications of AI and ML, and you also looked at different types of artificial neural networks and their usages. So if anyone missed that workshop, you can find that workshop video on YouTube. So please go through that one. It will help you understand this much better. So now today what we are going to look at is we're going to look at how machines learn using neural networks, and we are also looking at these different types of neural network layers, and how we can use them in specific applications. For example, if you have images that needs to be recognized, what sort of a neural network do we need to use at that point? Or let's say we have sort of like a paragraph or couple of sentences, and we want to understand what the user has written. So in that kind of a scenario, what sort of a neural network do we need to use? So, and then we're going to look at certain libraries, APIs, and already available and trained models that we can use in order to achieve uh, these objectives. So the beauty of using these libraries and APIs is you actually don't need to know how to implement these neural network models, or be concerned about the mathematics behind the neural networks. If you simply know what sort of a neural network you will need in your problem, you can basically use that one, uh, use a pre-trained model without having to worry about anything else. And then we're going to look at another branch of machine learning, which is reinforcement learning. And if we have enough time, we will cover different libraries and APIs for reinforcement learning as well. Um, so I'm going to post a small poll and see if you can answer this poll in a couple of seconds. It doesn't have to be a long answer. It's just a short answer would be fine. I'm going to end the poll in about 5 seconds. So if you have your answers, please send them. Okay. So how do humans learn? Humans actually learn from a couple of different ways. The main way we humans learn something new is by trying it out, or by our past experiences. So if we have seen something beforehand, we know what it is about. Let's take a small example. So let's say you actually you have never played basketball, and you're trying to play the basket. You have the basketball with you. You're trying to put it in through the hoop. So the first time you try it, you aim it at a specific angle, and then you try to throw it like this. Then the ball most probably will not go through the hoop, and you will see you will get some feedback. You are seeing that the ball is not going through the hoop. It's going far beyond what your target area was. So what you do next is you adjust the angle that you try to shoot it up. So you're changing, you're learning from that experience, you're learning from that mistake, and change your approach. So if you do this a couple of times, then eventually you will be able to perfect this activity. So that's basically how we humans learn. That's basically one way of learning. So is this method really effective? I hope it is effective, because otherwise, I mean, if it wasn't effective, we would all not be able to learn much throughout our lives. So now the question is, can we imitate this same idea? So if we try to imitate the same idea, uh, it's a really simple idea. So you try something out, and then you sort of change the way some of the parameters of your activity, and then you will be able to perfect whatever the activity that you're trying to do. So the idea behind machine learning is to try and imitate this behavior. So in order to imitate this behavior, we use artificial neural networks. So I'm not going to go into what artificial neural networks are, or the math behind these learning updates and all that. But if you're interested in it, there are a lot of resources available in YouTube. You will be able to, if you're interested, you can learn a lot from there. So now what I want to focus now is on these neural network types. Before I go on, if you have any questions or any doubts about what we are doing, you can always type your questions on chat, and I'll answer them as I get those questions coming. So we have different neural network types. So like I mentioned earlier, because nowadays we have a lot of implemented models and libraries and pre-trained models, we actually do not need to focus about the mechanisms behind all these neural networks. It is simply sufficient to have a general idea about how and where we need to use each of these different neural networks. So can someone can you type out what you know so far? For example, like different types of AIO machine learning models. For example, I'll give you an example. We have something called natural language understanding, which deals with text inputs or speech recognition and all that. Do you have any ideas about anything like that? Yes, we have okay, and we also have computer vision. We have robotics. We have robotics that deals with navigation problems, and we have different things like that. So basic building blocks of most of these deep learning, deep neural networks are these smaller components. So we have something called a linear neural network layer. The difference between these layers are what type of data they can handle. For example, these linear networks, they can easily handle simple inputs. For example, let's say we want to input student ages and then categorize them or classify them according to their age. So if you want to input a student age, then we can simply use a linear layer to handle that input. And then if we have, more complex structures like images that have, a lot of data in it, for example, an image. So let's think of this as an image. Image is usually broken down into its pixel level components, and then each of these pixel points are considered as a single data point. So in order to handle this type of complex inputs, we can use convolutional neural networks, where it consider a set of pixels, and then it tries to learn or observe what is in these sets of or different blocks of neural networks, different blocks of pixels. And then we have something called recurrent neural networks that can deal with sequential data, or else a list of data that is related to some sort of a time step. Let's take an example. For example, we have prices of vegetables. Let's say we'll take an example. So we are trying to guess, or we are trying to predict the time of the price of potato. So if we know the past prices of potato for the last month or so, then we can use that data in order to predict what the value of potato is going to be on the next day. So in order to handle that sort of time sensitive, like time related data or a series, we can have recurrent neural networks. And so there are different types of these layers and networks. I'm not going to go into detail about each of these ones, but what I will do is I will point you towards some resources that you can browse afterwards to get some sort of a idea about these networks. So now, like I mentioned earlier, we have different libraries and frameworks. So in this workshop, I'm mostly focusing on Python-based libraries, because that's the most easier to use language for data science and machine learning areas, and it's really easy to learn. And it has a lot of these libraries and pre-trained models that you can easily use as well. So now if we want to implement these layers, we have to go from scratch and start to go behind all the math, and then build it from scratch. But with these libraries like TensorFlow or Keras, PyTorch, we already have these basic neural network layers built in them. And in cases like Keras and PyTorch, so Keras and PyTorch, they already have already pre-trained models in those libraries that we can actually reuse without having to go through a lot of trouble. And nice thing about PyTorch is they also have, even TensorFlow has that, they have good documentation that you can browse easily. So I'll go to that and show you a couple of pages from PyTorch documentation. This is PyTorch documentation, which you can access through the links found in the presentation here. It will be shared with you all in the resources. And so if you go here, you can see different layers. And if you go into these different layers, you can actually see all the math stuff and how they can be used, as well as some examples at the bottom of how you can simply use it. So in order to use these layers, layers to build a neural network, you don't actually need to know how each of these layers work or the math behind these layers. But then you have all these different networks that you can browse through here. So you have different types of layers. Like I mentioned earlier, we have pooling layers, we have different padding layers. So whenever you want to try something out, if you think you want to go with a CNN, we know CNNs can handle complex structures like matrices or images. So in that kind of scenario, you can come to these resources and then browse through them and decide on what to go with. But we actually don't need to if we are simply focusing on applying already existing models, we actually don't even need to go that in depth right now, because there are a lot of already built up models. So a deep learning model is usually a single deep learning model consists of multiple neural network layers like this. So if you're going to build a computer vision algorithm that can recognize different objects, you will have to first focus on this CNN, and then you have to have a couple of CNN layers combined with some other layers, and you have to build a complex deep learning model in order to detect different objects from that. But nowadays we have different frameworks like PyTorch and Keras. These frameworks allow us to load already existing models. So now I'll show you some of these online tools, and then we will go and look at how we can reuse existing models, how we can search these existing pre-trained models, and what sort of resources we have that we can use for us to learn these machine learning models. So one thing is TensorFlow Playground. This sort of lets you try out different neural networks, different neural network structures. So for example, it's this is the TensorFlow Playground, and so if you go below here, you will see some description about neural networks and how you can use this tool. So basically what you're seeing here is neurons. So these are different neurons, and a combination of a set of neurons like this is what we called as a combination of these ones are what we call as a neural network layer. So you can decide to add different layers here. And what you see on this right-hand side are the data. So in machine learning problems, what we usually try to do is, figure out uh, some sort of rules uh, to, try out on different, we have certain data, and we want to learn the rules that could be used to generate these data points. So what we do is, so we have data sets, data points like this, and the ones that you see in yellow color do belong to one specific class, and then once you see in blue color belongs to a different class. So we will simply have a single hidden layer and inputs, and then we'll run this one and see how our algorithm can learn this structure. So you can see, you will see this is getting changed, and it is trying to learn which area is blue and which area is orange. Okay, so now that was a simple data set. So let's go for a more complex one. So now we have all these ones spread out. Now if we try to use the same neural network on this, it will be a bit difficult to learn everything. You'll see some of these yellow color ones cannot be captured correctly. So if we add some more layers here, and let's say we had a couple of more and we'll try it now. Now you see, by changing our neural network layers, we were able to capture what we need. So that's why I mentioned it's what we need to know is basically for a given problem, what sort of a structure we need to have. So at your level, it is actually difficult to go outright and build all these different layers by hand. So what we can do is we can actually reuse existing models that we have. And another resource that you could use is Google Colab, which is sort of like a online editor that you can use to develop machine learning models or run machine learning models, or even you can do basic Python programming. It is basically a Jupyter notebook that is hosted on Google servers. So if you're trying to do something that takes a lot of resources and your computers are not up to that capacity, you can simply use a tool like Google Colab. So these can be used to train different neural network models if you wish to, or run different simulations. You can use a tool like Google Colab. Now, next thing I want to show is how we're going to implement machine learning models, or like more than implementing, how we can decide what sort of a machine learning model we are going to require for different problems. So the first thing that we need to do is analyze the problem, look at the problem. So as I mentioned earlier, if our problem or the problem space is related to computer vision, we need to go with the algorithm or machine learning model that is capable of handling computer images or videos, and you know that kind of inputs. And if we want to have an algorithm that, if our problem is something like predicting the vegetable prices, stock market prices, then we need to go with an algorithm that is suited for that kind of a scenario. So that's why analyzing the problem that we are facing, analyzing the problem that we need to solve, is the most important part. Let's take a e-learning application, for example. So let's say we are building application that helps young children to learn how to write digits. For example, we want to teach them how to write number 1, number 2, number 3, and so on. So any idea what sort of algorithm we will need to do that? So in the application, what we are doing is we are asking those children to write number 1 and then hold the mobile camera on top of that piece of paper. They have written number 1, and then our application will capture that image, and we need to sort of have a machine learning model that can detect whether the student has written it correctly. So what sort of a model do we need to go for in that kind of a scenario? Do we need to go for a computer vision based algorithm, or do we need to go for algorithm that's more capable of converting images into text, like a OCR, optical character recognizer, which uses optical inputs to recognize different characters? So the best thing we can go for is something like a OCR model in that scenario. So whatever the application that you're building, whatever the problem you are trying to solve using machine learning, first thing that you need to do is analyze these problems. And then it might be difficult to, so in regular programming, we know if we want to define some rules, we know we can simply define those rules using if else conditions, and it will work. But in the domain of machine learning and AI, things don't usually go as planned. So rather than focusing on a single algorithm, then we usually decide on a range of algorithms, and then we try a couple of algorithms and see which one works the best. So that's why I said, if we have computer vision related problem, there are several computer vision based algorithms that already exist that we can reuse. So it's always better to keep our options a bit open and select a range of algorithms at an initial state to try out. And then So now, machine learning algorithms do always depend on data. So if you're trying to, train a machine learning algorithms, you're going to need a lot of data in order to train that algorithm. So that's why we usually prefer to use, already trained, pre-trained models in our applications. That takes the hassle of, finding data sets, training all the, machine learning algorithms. We don't need to worry about that if you're using a pre-trained model. All right, and then we need to test. So in the second stage, I mentioned we need to, use a certain range of we need to, try out a range of algorithms in most of the cases. And if you have a range of algorithms developed, and if we test those algorithms, then we can, decide on the algorithm with the most accuracy, and go with that algorithm. Now, since we're going to focus more on using pre-trained models, I'll talk a bit more about how we can choose the pre-trained models. So if we want to, use different pre-trained models, we have different couple of different resources that we can look at. So we'll look at that one in a couple of slides. So when we try to choose the model, we need to focus first on the problem itself. So since we have analyzed the problem, then when we are going to choose the model, we know what our inputs are going to be like, and then what our outputs should be. So there are all right. So we have a couple of different outputs from different machine learning models. So one of the most common things that you would have seen is, we need to identify different objects. So in a computer vision algorithm, we are going to show the computer vision algorithm different objects. And what we want that algorithm to do is to classify these objects, right? So in that kind of a scenario, we need to go with a classification algorithm. And if we go back to our neural network playground, we will see two different problem types here. One is classification, and then the other one is regression. This regression is more like predicting set of values rather than classifying. So we need to go for a regression based model if we want to predict prices or predict a certain value. But for a classification problem, we typically use a classification problem to to in cases where we need to identify whether this object is a car or whether it's a mobile phone, and we can use that for gender classification as well. So if, let's say, we are given a set of images of students, and we want to identify male students and female students. So we have two different classes there, and then what we want our algorithm to do is classify them. And there are a couple of other different algorithms, what we call as clustering algorithms, that we usually use. Clustering algorithms, for clustering algorithms, we actually don't need labeled data. So like I mentioned earlier, one of the main problems that we have to deal with in machine learning algorithms is it needs a lot of labeled data to train that algorithm. But for a clustering algorithm, we actually don't need to rely on labeled data. What a clustering algorithm does is we give it all the, we'll take the previous example. So we give a clustering algorithm all the images of male and female students, and we try to run the clustering algorithm. And if we want to have two different clusters, it will probably try to cluster these students based on some sort of a feature. So in this case, male and female. So it will cluster similar images together without having to have so the difference is, if we use a neural network, we need to teach the neural network first. So we need to show a picture of male student, and then show it, then specifically tell it that this is a male student and this is a female student. And after training like that for a while, a neural network will be able to identify whether an image we show it is a male or a female student. But for a clustering algorithm, it's simply sufficient to give all the images, and then it will cluster these students into groups based on how we define parameters in the clustering algorithm. And then reinforcement learning algorithms. So in the last lecture on AI, last workshop on AI, you were shown a cool Atari game, I believe, that was developed using reinforcement learning approaches. So reinforcement learning approaches is sort of like a reward-based learning approach. If I take an analog there, let's say in school, if you do your homeworks well, like in kindergarten, if you do your homeworks well, you used to get nice little stars there, right? So if you get a star, you know you have done something good, and you want to obtain more stars. So you try to keep up the. And later on, let's say when you come to your O-level classes, if you behave badly, sometimes your school teachers may have scolded you. So if you don't want to get scolded, in front of your friends and all the classmates, because like, let's say you get scolded today for doing something terrible, then the next day, before you try to do that, you will realize, if I do this, I will get punished or humiliated. So I'd better not do this one. So that's what we call as negative and positive reward based learning, which is what happens in reinforcement learning. So in that Atari game, what happened there was, it failed to point towards the correct spot to redirect the ball at first, but after failing and regaining the losing the game couple of times, it tried to do things so that it will not lose the game, and ultimately it was able to, perfectly win the game. Okay, we already talked about these a bit. So if we have images and videos as inputs, we can use computer vision algorithms which are based on convolutional neural networks. And if we have, if you want to identify numbers or text, if it's a written one that contain images, obviously we have to go with computer vision algorithms again. Or if it's just typed out numbers, then we can simply use linear layers. And if it's a sequence or a time related data, then we can go with recurrent neural networks. And then about these data sets, we don't actually need to worry about data sets, because we at your level, you will most probably be using already pre-trained models. So I'm not going to talk about data sets that much. Okay, so now we come to the most important part of this session. So what I mainly want you to take out from this session is this part: how we can use existing models in our app development phase. So there are several resources like huggingface.com and TensorFlow Hub. So I recommend going with TensorFlow Hub, because they have a lot of resources for filtering out reinforcement, filtering out different machine learning models. So the good thing about these existing pre-trained models is they're really easy to use. Usually how you can use them is already shown in your in those examples as well. So you don't have to worry about doing anything else. You can simply use it as a different API, and then you can simply predict different values. And okay, so let me show you how it looks like. So this is a TensorFlow Hub homepage. So if you go down here, you will see different domains, and you will see a text problem domain here, and then image domain here, and you have video and audio related domains as well. So depending on what and how you want to use, depending on the problem that you are trying to solve, you can easily find a pre-trained model that will help you successfully complete your project. So let's take this image problem domain. So we have image classification examples, and we have object detection examples. We also have image segmentation there. So we have pose detection, which we can use to detect different poses of humans, whether they are standing, sitting, and likewise. And we have text recognition ones, and we have some algorithms that can detect depth in an image. So if you want to calculate a distance between two objects in an image, you can use these kind of algorithms. So let's go into object detection here, and you will see different object detection algorithms here. If you go into some of these, you'll probably see, you know, it'll probably redirect you to different, you know, it will redirect you to different tutorials even, so that it will help you. I did learn these things much better. So this hand skeleton model, it's for a JavaScript based algorithm. That's why it says .js here. So this one can be used to detect hand gestures by when you point your hand like this, it'll map out all the hand skeletons it can see. And you have iris recognition algorithms, and these YOLO algorithms, they are what we call as you only look once algorithm, and you can use these algorithms to do object detection. So if you click here, it will open up a Google Colab notebook, which you can easily. These notebooks are usually well documented. You can easily it will guide you through the entire process of how you can find out how you can develop different algorithms with how you can use these algorithms in your application. So all these ones are just development parts for the application, which can be replaced by like if you already are building an application with let's say some sort of a drag and drop tool like Scratch, then you can do that and then simply plug in these models by following these examples. This one is a pretty big one because YOLO algorithm, it lets you detect more than 80 different objects that are found around us. So that's why this looks a bit complicated, but depending on what you need to use, you can find those related algorithms here. All right. And similarly, if you go here, if you go to audio domain here, if let's say you're building a e-learning application and you want to integrate a chatbot there, and you need to have speech to text capabilities for your algorithm. You can simply use something like this speech to text model and create a speech to text application. So let's see, this one is English version. So you have an example usage here as well. So if I were to explain this one, so these are basically like if you are actually reusing these models, you just need to follow these given examples, and you can simply do it. So this part here is what loads the already pre-trained model given here. So if we didn't have this part here, then we will need to go back to the very beginning, and we need to develop all these models from scratch, layer by layer, like shown here, like shown in here. We need to add different layers. We need to create different layers like this, and then see if they work, and then we can we need to develop these models by hand. Whereas if you're using a pre-trained model like this, we can easily integrate it. And then the other thing is we can also use different libraries. For example, there are text recognition libraries, there are object recognition libraries. There are a lot of different libraries. For example, I'll show you an example here. This is a usage of a library called PyTTS, which means Python text to speech library. So if we look here, okay, we might need to install different requirements here. So these are basically requirements that are needed to be installed. But the actual development part is only these few lines. So you import the library that you want, and then you can simply initialize that library, and then you can type out whatever that you want to make this library say, and then simply run it. So if you let's see, we'll run this and see, it should generate a file. There seems to be some sort of a technical issue here. So what I wanted to show you was that we can simply use these libraries that are available out there without having to worry about how different models are implemented, what these models contain, what's the math behind all these models. So it's really nice to be able to learn like use machine learning models in our applications without having to actually know the meaning or know the inner workings behind these algorithms. So you can use resources like TensorFlow Hub and different libraries like there's a computer vision library called OpenCV. I have given you a link to it somewhere here. We have something called OpenAI Gym. I'll show you that one as well. It's a nice resource that you can use. So this is this OpenAI Gym gives you different environments that you can use to train reinforcement learning algorithms, basically. So this one here, you have all these Atari games and all that. So you don't have to worry about implementing these UIs, these games and all that. All that is given there. What you need to focus, you can simply focus on developing the machine learning part without having to worry about anything else. And I'll show you a couple of videos here that have used those games. Let's check this one out. So this was actually done in Unity engine, which you all probably know is a game development engine that is being widely used. So this is actually okay, you'll see the target is to go past all these cars and collect these gifts. So after about an hour of training, it learns how to collect most of these boxes, but it still uh, can't win 100% of the time. So these were developed using reinforcement learning algorithms, and they actually learn by experiencing it for themselves and learning by making mistakes or getting those rewards. And moving back, we have different robots that can learn to walk by themselves. Um, take a look at this one. So all these walking, these different robots were simulated, and they were never taught how to bend those knees and all that. What they were given as input, I mean, they were simply given a goal, that is to go from one location to like starting point to the end point, and they actually learned how to do it by trying it out uh, like itself. So if you think about this, like when we are like when if we compare this to a small child, even a small child doesn't know how to walk. It starts to walk by trying different things, and then ultimately it tries to get take some trial and error into you know getting up. So yeah, this is a actual robot that was uh, it's a similar scenario. It was asked to go from this end to the other side, and this is how it at the initial points it starts to learn. You'll see it moves little by little. After 18 minutes, it actually learned how to walk correctly. And after it learns to do that, even if you give it different obstacles, if you try to push it out, it will still figure out a way to circumvent all that and go where it needs to go. If you see here, so you'll see starts walk, and then it gets pushed back again, but it still manages to uh, walk forward. So these are some cool things that you can try with machine learning and AI. Unfortunately, we don't have enough time to go into these machine learning concepts and how to actually start them from scratch and do it. But I'll point you to several good resources. So we have different, let's say, there are different examples over here at Kaggle. For you can use this like Kaggle as a resource for starting from basic machine learning models up to developing large scale very complex machine learning models. So Kaggle actually has it gives you different data sets and all that. It has all the resources for finding data for different problems, as well as actual solutions to those problems as well. So this one is about predicting prices of houses. They have given a data set, and that data set has average income of the area where the house is located, and the address, price, and all that. So you train a simple machine learning model using this data. So here it uses a machine learning library called sklearn, and it's actually using a already implemented, already available method, already available model, and training it to get the data. So you can browse different data sets and competitions here. You can find a lot of so this Titanic data set, that's a data set for actually this is the real data set for Titanic passengers who have survived and who have drowned. So your task is to based on the given data, your task is to predict whether a given person will survive the disaster or not. And you also have this one where you need to detect handwritten digits, and they have done it using CNN based models, and you can see different examples given here as well. And yes, so that's all I had to show you today. And if you have any questions, I'd be more than happy to answer them. So please, if you have any questions, please type it out in the chat window here. Sorry, I actually don't have access to CodeFest FB page. Okay, so if you all right, so if you don't have any questions, then we'll wind up this workshop today. And thank you all very much for joining.